Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 32, Database Security Hardening. Alice, we've spent the last few episodes on encryption, key management, secrets, and PII. This feels like the episode where all of that converges, because the database is where everything actually lives.
That's exactly right. Every security control we've discussed, authentication, encryption, input validation, access control, exists to protect data that ultimately lives in a database. Client communications, case strategy, privileged documents, financial records. If an attacker reaches your database with unrestricted access, every other defense has failed. So this episode is about the last line of defense, and ideally the first line too.
Let's start with the most basic question. Where should the database sit in your infrastructure?
As far from the internet as physically possible. The most fundamental database security rule, and the most frequently violated, is that your database should not be reachable from the public internet. Period. It should sit in a private subnet, which is a network segment with no public IP address and no direct route to the internet. The only things that can talk to it are your application servers, which sit in a different subnet. Think of it like a vault inside a building. The public walks into the lobby. Employees can reach the offices, but the vault is behind a locked corridor that only authorized staff can access, and there's no window to the street.
And in practice, on a cloud provider like AWS.
On AWS, your RDS database instance goes in a VPC, a virtual private cloud, which we covered back in episode 11, with public accessibility explicitly turned off. Then you set up security groups, essentially firewall rules, that only allow inbound connections from your application server's security group. Not from 0.0.0.0, which means anywhere on the internet. That's the single most dangerous misconfiguration in cloud databases, and I've seen it in production.
That's a scary default. What about the connections themselves?
TLS. Every connection between your application and the database must be encrypted with TLS, which we covered in episode 13. PostgreSQL supports it natively, but here's the catch. It is not enforced by default in many configurations. You have to explicitly set your client's connection mode to verify full, which means the client checks the server certificate and verifies the hostname. Weaker modes like prefer will silently fall back to an unencrypted connection if TLS negotiation fails. And that silent fallback is exactly what a man-in-the-middle attacker exploits.
So encrypt the connection and verify you're talking to the right server. What about the account the application uses to connect?
This is where the principle of least privilege, which we first discussed in episode 8, becomes critical. Your application's database account should have the absolute minimum permissions it needs. It needs to read, write, update, and delete records in the application tables. It does not need the ability to create or drop tables. That's for database migrations, which should run under a separate admin account. And it absolutely should never have superuser access. Superuser bypasses every access control PostgreSQL has.
Yeah, and I imagine this matters even more for multi-tenant legal SaaS, where one database holds data for many different law firm clients.
Exactly. And that's where row-level security comes back. We introduced it in episode 8 in the context of SQL injection. RLS is a post-contextual feature that automatically filters every query based on the current user's tenant identifier. You define a policy that says, this user can only see rows where the tenant ID matches their own, even if the application code has a bug, a missing where clause, a broken filter. The database engine itself blocks cross-tenant access. It's defense in depth at the data layer. Your application code should filter by tenant. RLS guarantees it.
That's a powerful safety net. What about logging, knowing who accessed what?
Database audit logging is your forensic record. It captures every connection, every query, every schema change. At the database level, not the application level. This matters because it catches direct database access that bypasses your application entirely. For PostgreSQL, the PG audit extension is the standard. It provides detailed session and object-level logging. The CIS PostgreSQL Benchmark, a security hardening guide from the Center for Internet Security, mandates enabling connection logging as a baseline and recommends statement logging for all data definition changes at minimum.
And where do those logs go?
Critically, not on the database server itself. If an attacker compromises the database and the audit logs are stored on the same machine, the first thing they'll do is delete the logs. Your audit trail disappears. The logs need to be shipped to a separate system, a SIEM, which we introduced back in episode 7, where they're stored immutably. The attacker would need to compromise 2 independent systems to cover their tracks.
Yeah, that makes sense. Now, backups. Those seem like an obvious target too.
Backups are copies of your crown jewels. An unencrypted database backup stored in a misconfigured cloud storage bucket is every attacker's dream. All the data, none of the access controls. Requirements are straightforward. Encrypt backups at rest using KMS keys from episode 29. Restrict access so the accounts that can reach backup storage are separate from production database accounts. And test your restores regularly. An encrypted backup you can't actually decrypt and restore is not a backup. It's a false sense of security.
Any real-world context on why this matters for law firms specifically?
Halcyon tracked over 200 ransomware incidents targeting law firms between 2025 and early 2026. The INC ransom group specifically exploits vulnerabilities in remote access tools, Citrix, Fortinet, Simple Help, to reach internal networks, and from there, the database. The average cost of a data breach for law firms in 2024 was $5.08 million. Network isolation, encrypted connections, least privilege accounts, audit logging, encrypted backups. These aren't theoretical best practices. They're the controls that determine whether a breach costs you $5 million or whether the attacker hits a wall and moves on to an easier target.
Next episode, we start Module 8, AI-specific security, with prompt injection attacks. Why the biggest vulnerability in AI-powered legal tools is fundamentally different from anything we've covered so far.
Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.